So what do you think, guys? True or false? If a function is continuous, it's differentiable. True or false? Okay. What's an example of something that's continuous but not different? A corner.
I'm gonna say an absolute value.
Absolute value. A seagull. Vertical tangent. However, can I have a function that's differentiable but not continuous? Or if it's differentiable, does it have to be continuous?
Yes.
That's true. False. And, might as well indoctrinate you now. For your response questions on the AP exam, there are 6 of them. There is always one question, and I seem to have to grade it every year, where they tell you, hey, we have this differentiable function, blah, 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 blah. As part of your proof to them on why something is true, you needed to say, because you told me this, I know that. And because it's continuous, oh, then intermediate value theorem holds. And because intermediate value theorem holds, because I went from a negative y value to a positive y value in the spectrum that you're talking about, it must have hit 0, or whatever. They will hit on something that you needed to say, I know it's continuous because you told me it's differentiable. It's those stupid little details. I'll tell you this like 25 more times through the year. You'll eventually be like, yeah, I heard. Today's applications, sort of derivatives. This is off an old quiz, which by the way, you have a quiz on Tuesday. This was 4 points. I want you guys to try and graph it on your own, like on the same plane. So on this thing, what's a possible graph of derivative? Finding it hard to do attendance because I can't. Zach, I saw you. Yeah, there you are. You were hiding behind Julia. Evan knows keys. Do you agree? No, Evan? It's hard taking attendance when the whole city chart just changed. You're like, wait, see it's filled with the wrong face. Anyone want to try? Yay! Uh-huh. Yay! Well, give it a go. Experimenting. So So derivative is the graph of the slope.
Oh, we don't, okay.
And we can use.
It's okay. No, it's wrong, yours is right. Okay.
Well,
On top of the same axes.
okay, well, I thought because it's a parabola, it's gonna be a linear derivative.
Yes, I agree with
and
you.
It's gonna hit 0 like here.
Yes, I agree with you.
But then I wasn't sure if that'd be positive or negative. but
So
I
think
guess
about it, what kind of parabola is it?
It's a negative.
So the derivative of a negative x squared would be,
Negative 2x.
so is the line gonna be a positive slope or negative slope? Yep.
So, like that, and then this one's positive, so. And then this is linear, so it would be like just like a straight line.
Okay,
So it would just be like across like that.
and what about, so you did open circles on those guys, what about the other two lines?
Oh,
Okay, so the way this is graded, there were 4 points. There's one for getting this straight line to intersect at the zero that she said there's a horizontal tangent there, the derivative's gonna have a value of 0 there. It was a negative slope, so 1 point for getting the 0 rate and the negativeness. She's right that this was just a linear, so it's a constant and it's positive. That's correct. This, there's a horizontal tangent there, the derivative's gonna be 0, and it's gonna have a positive slope. So 1 point for each of those. These guys need to be open. You can't do the derivative at a corner, curvy corner, anything like that. And the endpoints, these guys, open or closed, I'll take either one. AP will never ask you about them. So that's how this would be graded. So this would have been a 3 out of 4 for getting all the lines basically right. Some of you might have had more steep stuff. The important thing was that it was a negative slope and that it began and stopped at the right places and it hit 0 in the right place. And this horizontal line, again, something positive anywhere. And this slope, anything positive, but it had to hit the 0 there. Good? That's the elements that we're looking for. Okay, instantaneous rates of change, we did this already. And in case you don't remember, this is how to find the instantaneous rate of change. It's one of the limit definitions of derivative. Trying this. So brain trust in the back, what are you discussing? Michael, what do you guys think? So find the rate of change in area with respect to radius. Rate of change, I didn't say instantaneous, but if I'm asking for average, I needed to tell you A to B, right? So I'm gonna guess I want the instantaneous rate of change of area with respect to radius. How do I do that? Okay, so what is the derivative of area? Okay. the derivative of y? Okay. Flynn, what is the derivative of y? Okay, Amelia, what is the derivative of area with respect to r?
2 pi r.
Gee, the derivative of area gives you the circumference. How cool is that? And this is for the physics department. It's not just when I ask you guys to put it on the board, always, always, A prime. Area can change by lots of different dimensions. Tell me, how is the area changing with respect to the radius? Evaluating that rate of change, just showing you some notation. The straight bar means I'm going to take the outcome of the ADR, and this stuff down here means I'm plugging in for R. I get 8 pi, did I give units? I did not. So it's 8 pi, I don't know. Sorry, that's a thing I still have to work on. Scientists complain to us that you never ask them units. Yeah, I don't really care. And significant figures be damned. How many decimals do we round to in here? 3. How many people? 18.576, because I said so. You either round or truncate. What's the difference between rounding and truncating?
Truncate, you just cut it off.
Truncate, you just cut it off, which is what most of you do. You go, here's your 3 decimals, I don't care if the last one's a 9, I'm just gonna cut it off. Okay. Okay. I don't know why, but it's a convention. S, they use the letter S for position. I don't know why. But as position changes over time, so change in position over time, what do we usually call that? Displacements. Displacement is just change in position. Change in position with respect to time is velocity. So this is just showing you, I don't think you need to write this down, guys. This is, what is this? As dt, delta t goes to 0, what is that? Limit definition of derivative, right? So they're saying the derivative of position is velocity. That's what you need to get out of this. Average velocity is same as the average rate of change. What is your position at the end? What was your position at the start? How much time changed from start to end? That's average rate of change. Because if you walked this way and then back again, and you ended up where you started, your displacement was 0. Clearly, your velocity at any given time would have been positive, then negative, and it averaged out to be a 0. Instantaneous, right here, those are different values. Okay, velocity, again, just instant rate of change of position. Absolute value of velocity is speed. Speed doesn't have a direction, it's just you're going 50 miles an hour. Velocity is a vector. It's got direction. I said this yesterday, but again, positive velocity in the vertical direction, is it up or down? Oh, okay, thank you. And positive velocity in horizontal direction, right or left? Okay, just checking. very upset that I never actually specified that positive meant to the right in my horizontal direction. Well, how was I supposed to know? I don't know, maybe because the number line, positives are over here and negatives are over there. But no, we had an argument and he did not win. Positives are up, negatives are down. And speed is always positive. I am screaming along in whatever direction I am going at this rate. Derivative of velocity is acceleration. How is your velocity changing over time is acceleration. Projectile motion from pre-cal. This is the component with gravity. I thought gravity was negative 32. How come this is a 16? Because of calculus. Sebastian, what's the derivative of my position?
Just negative 32. Oh, plus 120.
Physics friends, what's the 120? Anyone in here in physics? Yeah.
Wait, is that the initial velocity?
Yeah. So we did this in pre-cal too. So now double derivative of position with respect to time is the change in velocity with respect to time, which is the acceleration with respect to time. And we get negative 32. What is the negative 32? Just gravity. Just gravity. In feet per second squared, which, what is it in meters per second squared? 9.8, negative 9.8. But we like 32 because it's like a nice even number and it divides by 2 nicely. Okay, so just double derivative of position is acceleration. You don't really need to know these, but there it is. English units, gravity is 32 feet per second squared. It'll be given to you if you, like, it'll be wrapped in the equation already. You don't need to know them. Okay, without a calculator, I want to know, I shoot something or other up into the air, vertically, straight up. What's the highest that it can go? Because gravity does exist. How are we gonna do that? You're all looking at me like, what? Okay, let's watch the pen go up and down. Woo! It turns around. So when does the position stop going up and start coming down? Hint, hint, it's got something to do with it.
When gravity is greater than the force.
When gravity takes over, okay, yeah.
When it hits 0.
When what hits 0?
Your
Velocity. So we have positive velocity going up, negative velocity coming down. What is the velocity right when it changes? 0. So find velocity. Find when the velocity is 0. Stella? No?
I got it. It took me a second.
Should I throw it somewhere?
Well, I was like, I couldn't see that original equation, so I was like,
Frankie, you know what is velocity?
You find the first
What is velocity?
derivative, and then you plug 0 in
How that
as the, not as the t though, as the y.
Like, what's negative?
why are they related?
I don't know.
In physics, what do we?
Yeah.
A change of position over time. No, what does that mean? What does it mean? When Ms. Pascal said that we.
What was this last year? You get five? Yeah, I got it.
Yeah, so what is that? Like change position over time.
Wait, oh my god, so. So that's position. Yeah, that is velocity. Yeah, so, and then the velocity, try to find a maximum, you make it zero, yeah, make it change. Because when the velocity is zero, that's when it's gonna start to turn. That's the time, is that the time though?
Sadie, what's the velocity?
Oh, wait.
Alright guys, so what did you get for this? There's my velocity, and I coaxed you into saying, what is this when it's zero?
Oh, wait, negative 32. Oh, wait, no, plug it back in.
And I said no calculator, so what is the answer 5? No. Okay, so those of you who haven't taken the SATs for the 18th time and still have yet to take them, yes, the velocity is going to be 0 when I get 5 seconds in. What did I ask for? How high is it? So you need this answer. Now we need to plug 5 into that, which, okay, I don't remember. But, what is the height? And that, I don't feel like doing the arithmetic. What? It's morning, I don't have to. Oh. Yeah, how does A make sense? It doesn't. Okay, 160 times 5. Yes. Okay. Yes, which I'm not arithmeticing right now. Ray, how do we find when the speed and velocity of the object are 256 feet high?
You just plug it in, press the key. You just set the 160t minus 240t.
So take the position function and set that to 256, which I'm gonna move it over. 256 is 16 squared. So if I factor out a negative 16, so my answers are 2 and 8. No, because again, I asked what is the speed and what is the velocity. So the object went up and it came back down. There were 2 places that it was 256 feet in the air. What was the speed at that time and what was the velocity at that time? Well, speed is 96 on the way up and 96 on the way down. Velocity on the way up is 96 also, but negative 96 on the way back down. What were the units? Feet per second. acceleration, 32. Doesn't matter what time. Negative 32. Bothers me on those physics problem when they make gravity positive and when they round it to negative 10 meters per second squared. Bothers me. Okay, and when does the object hit the ground? I don't actually care about that, but in 10 seconds. Okay. All right, don't draw it. This is in your textbook. Eventually, you guys are gonna be able to look at this and know what's going on. If, oops. Is this a position graph, or a velocity graph, or an acceleration graph, or something else? Position. So, your position over time, you're walking away from something. Right here, are you walking faster than you were in the beginning? Yes, because it's a steeper slope. There's a greater change in your distance in the same slot of time. What is happening right here in your position? I've stopped moving. Like right here, I stopped moving, and some of you said you changed direction. I was walking forward, and now I'm walking back towards where I started. And no, you will, like, the goal is eventually, you'll be able to read this and be like, oh, well, I'm accelerating, my velocity is positive, I've slowed down, I am stopped. You'll be able to read through this and say where acceleration is positive, where acceleration is negative, by looking just at the curviness of the shape, okay? But the key thing is to notice where horizontal tangents are. On position, that means your velocity has stopped. You're at the critical point where things might change. All right, try these 3 questions. Compare your answers with the person next to you. And note this thing here. I finally put it on the slide that says you need a calculator, because people are like, how do you do this? Oh my goodness, you need a calculator.
No.
Okay, this is like the first way you've had.
And I don't think it works.
Yeah, take the one.
Yeah. Oh, exactly that.
27?
Yeah.
One particles being up on the final first. When you did the we don't have the terms and what do you mean stuff?
What you do?
Never reverses direction. How do we find when something's gonna reverse direction?
When the velocity goes there.
Okay, kind of. So I'm gonna do the derivative of position. There's the derivative of position, and again, I said you need a calculator for this, because when the numbers get ugly, when it doesn't factor nicely, we don't expect you to do, quadratic formula. I get those numbers. This is not a guarantee that it changes direction. As a matter of fact, the majority of the time that I'm driving and my velocity goes to 0, driving up, I get to a stop sign. Very, very rarely do I slam my car in reverse and go, just kidding, and back up. Very often I come to a stop and then I move forward again. So just because velocity is 0 doesn't mean I'm changing direction. Though I have stopped throwing the car in reverse, it doesn't happen most of the time. Our strategy, what we're gonna do to figure out, we're gonna make a number line, we're gonna name the number line. What is it? We're testing the velocity. We're testing x prime or s prime, whatever, the derivative of position. And I'm gonna put those numbers on there, and I'm going to pick a number in between here, like when time is 0. Plugging time is 0 into what am I plugging it into? This is the reason I named it. I'm plugging it into there. Plugging in 0, I get a positive. So from the start, the particle's moving forward. And then at positive 1, 12 minus 32 plus 15, it doesn't matter what the actual value is. What matters is that it's negative. So there, velocity changed sign. Now I've changed direction. When? At 0.60685. Then at picking 8 million, putting in 8 million, my velocity or my x prime is positive. I change directions at 2.060 if I actually rounded. We're gonna use this number line technique lots and lots and lots. Name your number line so that you know, and you're telling me that you're finding where velocity is positive and negative, or acceleration is positive and negative. I need to know. So interpreting this, sure, right, I know it's your phone making all that bloop, bloop, bloop. Someone's getting lots of messages, guys, please, like, thank you for putting your phones in jail, and make them shut up before you put it in there. Okay. So heads up, like support and proof on quizzes and tests, number lines are not enough. You need to then give words to the number line. The AP has written like pages long about their decision to change this, whatever now, 12 years ago. You need to say the particle is moving right at 0 to 0.6 blah blah blah, and again at 2 point blah blah blah, because the velocity is positive. The particle is moving left from 0.6 to 2 because the velocity is negative. Yeah.
How'd you get 2 and 0.6?
Well, I'm rounding. this on the calculator? Do you not know how to find this on the calculator? No, okay. Calculator tricks.
Ms. Pascal, how
Yeah.
because in between 0.6 and 2 is negative.
Okay. I will show you. Pick a number between 0.6 and 2,
never
like
mind.
1?
I got it.
Okay.
I got it. I was doing it wrong.
Okay. So the only emulator that I have is a TI-83, which is kind of crappy, but there you go. We're going to type it in, and we're going to graph it. There it is. It's a parabola. So to find, I want to find the zeros. So let's see. Above trace, the blue button, the fourth button on the top, is a yellow word that says calc. It's calc for calculate. So hitting the second button to, or the yellow button to get those calculate. Let's see, which one of those do I want? The 0. So 0. And then it says pick a left bound. And you can't see it blinking, but it's right on the y axis. There you can see it blinking. And it says, is this the left side of the 0 that you want? That's what that's asking. Left bound? Yeah, I'm on the left side of that 0. I'm going to hit enter. And then I can use the right arrow. And I see that the y value went negative, so it did cross over. I'm going to hit it again. And it says, am I on the right of where you want to see? Yes, I am. So when you hit enter, there's the 2 little sandwich bars up there. And it says, it's saying, should I guess? Which it really is guessing. It's doing calculus approximations with h being 0.001. Do not do intersect. Intersect is poopy. So, Franco, you good with this? But hang on, so I want to show you another trick. So I need to find another one because there were 2 coordinates. So right now, guys, please look up. Many of you don't know this trick. If I type in X right now, it is the value that it found for me. And I am going to go right now, I'm going to hit that stow button, that store, and I'm going to store that in A. Because maybe I want to find the position at that, and I can just do 4a cubed minus 16a squared plus 15a and find the position at that exact time. Okay? I'm going to go back to the graph. I need to find that other 0. So second calc again, the 0. Am I blinking to the left of stuff? Yes. Okay, here's another shortcut. If there's super curvy and you have lots of like mountains to go over, you know, it looks like 1, 2, 3. I'll be really cautious. I'm going to just type in the number 4. I didn't have to move my arrow. I was able to type in a number. 4 looks really far to the right of where I'm looking at. You can see the little sandwich bars. Yes, the function crosses. Hit enter, and I get my other value. And now, second quit. If I type in X now, it's the new value that showed up. And I'm going to store that in a different letter. All right? Calculator tricks. My calculator, I call it Jesus. It does everything. If you get lost, it shows you the way. Yeah? Okay. Quiz on Tuesday, you do not get a calculator. So not to get you all excited, yeah, you don't get a calculator. But some of you don't know any of the calculator tricks, and there will be rare moments that I will point them out to you. this is one for the moments. Total distance traveled, that question stinks. Okay, guys, there is no shortcut to finding total distance traveled by hand. So I needed to say, how far did I travel from 0 to that first turning point? 0 to 0.60685. Well, position minus position gives me distance traveled. But then I need to say, how far did I travel between 2 seconds and 0.6 seconds, and absolute value that. I might have been traveling backwards. I'm like, I want this mileage to clock on my Fitbit. Yeah, okay, I ran around the track 8 times. Net change, my GPS position is still 0, but I want my Fitbit to say, no, clock that 2 miles, I want that to count. So how far did you go to the left? 6 and some. Wow, someone's getting just way too many messages. And then the last bit, how far did you go back in the forward direction again? Adding all those together, you get your total change in position. Okay. Speeding up and slowing down. This is a more complicated question, which we will get to more with when we go over the homework. Please do the homework, in particular, question 24 and 25. Super, super tricky. This one gives you position. Guys, so for the homework, please read it carefully. This is a position question. Where's your position over time? So when when the slope here is flat, it means you're standing still. Versus this velocity function, what happens here when that's flat? You're coasting. You've still got velocity, and you're coasting.
Ms. Pascal?
Yes.
The chalkboard, is that positive?
Sorry? Chalkboard is wrong. The homework, there is homework. It's day 12.
So we put 2 anchors together.
13.
Not a valid valid.
Hey, Sita, what do you have in rhetoric?
19.5.
Yeah, I got a 14.
Amelia. Is that like the 3 that you put into the grade book and stuff?